Today we'll continue to talk about programming, and if you remember, we already mentioned that there is something that's called high-level programming language, and there is something that's called machine language. And the difference between them is that the high-level programming language, which you can see here, is something that we write and we understand, and it's a bit similar to English. You can see an example. I didn't put a real programming language commands, but this is very similar. So you can see the first command is start program, and then we have read a comma b, and then we have a equals a plus b. So you can read those commands one by one from top to bottom, and then at the bottom you see end program. So this is called high-level program or high-level programming language. And on the other hand of this drawing, you can see what machine language looks like. It's a bunch of ones and zeros. You could have machine language that has different numbers, like hexadecimal numbers, but the example that I put here is a computer that understands only zeros and ones. And the transition between high-level programming language and machine language is done by something that's called a compiler. Now, a compiler is a very complicated program that somebody wrote, and somebody wrote because they knew the language that we were using as high level, and they could interpret each and every command to the equivalent sequence of ones and zeros, and therefore any program that we give here and run through the compiler will output a section of a program or a program in machine language which the computer knows how to execute. So let's dwell on one point here in this drawing, and that's at the bottom where I say input stream or data. What is input stream? If you look at the program that's described here, you have start and then you have read. Read a comma b. So you can ask yourself, where do we read from? So the answer to that will become clearer and clearer as we do more exercises. But for right now, let's say that there is a place where we store data. We call it the input stream, and the data has the input that we need for the program. So in this case, I stored here two numbers with a comma in between. So the numbers are 17 and 20. So if the program reads a comma b, usually you go from left to right in the same order. So a gets the value of 17 and b gets the value of 20. And later on we'll see more things with input, but for right now let's just treat it as some kind of storage, and whenever the program issues a read command, it reads from that storage area. Okay, so now let's move on to another slide here, and let's look at some names of programming languages that are high level. If you look here on the left hand side, there is a programming language that's called C programming language, a very important language. We'll actually learn C as the first language. Normally people don't learn it as a first language because it's not such a simple language, but I will first teach you some simple parts of the C language, and as we go along we'll get more and more deeper into the language, and we'll learn more things, nicer things, and we'll be able to do many things. Even in the beginning we'll be able to do some nice things. Okay, the next language that I wrote here is called Pascal. Another language is called Java. Another language is called C++. Actually, C++ is a superset of C. In other words, C++ has all the constructs or all the statements and commands that C has, but it has more than that. That's why it's called plus plus. But anyway, we'll see that much later in our studying. For now, those are just names of few. There are many programming languages, probably hundreds and hundreds of them, if not thousands of them. And we'll concentrate on one, but we'll see that in other languages there are many similarities. And now if you look at the right side of the drawing here, it says machine languages, and that already depends on what computer gets to run the program. As we saw in the previous slide, the compiler translates from here to there, and the compiler of course interprets for each and every computer into the machine language that that computer understands. So we may talk about machine language a little bit more later on, but for right now just treat it as we write the program in high-level language, we run it through the compiler gives us machine language, and then we can execute that machine language on the computer and get the result that we wanted by writing that program. And here is a specific example from the C language itself. I wrote two statements or two commands. The first one says A equals 10, semicolon. Every command in the C language ends with a semicolon. So A equals 10 means I'm assigning the value of 10 to the variable A. We already saw examples like that, so this should not be new for you. And now we have another command, it's called printf, and we'll talk more extensively about those commands, exactly what they mean, how they do things, but for right now I'll just tell you that printf prints a certain thing. And it prints, if you see here the A, it will print the variable A, and it will print it as a number. So I wrote here in quotes, I wrote %d, that means it's a decimal number, and this is like a pattern, and this is the variable. So it really doesn't matter right now the syntax or how we write the print command, but just see that this is a printing of the variable A. So we wrote a very simple program putting 10 into a variable A and print that A. So this program will just print 10. That's all it does. And when it gets interpreted to machine language, in this case I wrote code that's in hexadecimal. Previously, in the previous slide, I wrote code that was in binary, but here it's just hexadecimal, and we'll review hexadecimal a little later as well. But this is just what I wrote here is not really accurate, but this is just to show you the difference between high level that we can read and write and machine language that's not comprehensible by humans, but the computer can only execute the machine language. Now, another important thing to remember is that high-level command sometimes gets converted to several machine language commands. So if we have A equals 10 here, it doesn't mean that only this line will say A equals 10, but it could be several lines that will do the same thing that one line does in the high-level language. And with this, we conclude the discussion. This is the preliminary discussion about compilers, interpreting high-level language to machine language, and this is part 3, if I remember correctly, of lesson 7, and there will be a part 4, probably 5 and 6 as well. So review this and let me know if it's too slow or too fast, and if everything is clear, and I may send you homework later. Thanks.